All right, we're ready to wrap this up. 3 problems left. Actually, I should have included problem 41 on the previous video because it's a problem where you have to use the sum or difference formulas. 41 says find the exact value of the expression. Looks pretty messy. Sine of 5 pi over 12 cosine of 11 pi over 12 minus cosine 5 pi over 12 sine Now the whole key to this is we're actually going to use the sum or difference formulas backwards. In other words, I got a 5 pi over 12 here and a 5 pi over 12 here. Let's call the 5 pi over 12 u. I got 11 pi over 12 and 11 pi over, let's call this one v. So here I got a sine. So I'm going to look do I have an equation that says sine u times cosine v minus cosine u times sine v? And I've got my cheat sheet here, and if I look, so I got sine cosine and then cosine sine and a subtraction in between. And I believe this equals sine of u minus v. That means this whole thing equals sine u is 5 pi over 12 minus, I ran out of room, but basically I'll rewrite it here. Since u is the 5 pi over 12 and v is so this whole thing simplifies to that, which I can actually combine these now. Sine of negative 6 pi over 12, which is really sine of negative pi over 2. And now I say, think of my unit circle. What's the sine of negative pi over 2? Of course, negative pi over 2 is right here. What's the y value of this point down here? It's negative 1, right? So that should be your answer. All right, the final 2 problems. If sine of theta equals 2/3, and they say theta is between 0 pi over 2, then they say find the exact value of the following. 4 parts. A, sine 2 theta, B, cosine 2 theta, C, sine theta over 2, and D, cosine theta over 2. 4 parts. Now actually, if you look, 2 theta inside, we call these double angle, because if you look on your formula sheet, you actually have some equations when you have a double angle. And here, because we have theta over 2 and theta over 2, both these are called half angles, and we have formulas for those. So let's start with A, sine of 2 theta. Sine of 2 theta, if I go to my formula sheet under double angle and I see sine of 2 theta, I can rewrite as 2 sine theta cosine theta. See, the whole idea here is when you've got something inside the trig function, something different besides just theta, then we're sort of stuck and it's hard to figure out what to do. But because of this formula, sine of 2 theta, we can rewrite, and look what we have here, sine of theta, cosine of theta. So we're back to what we like. So basically, for these conditions, if I can figure out what the sine of theta is, and I actually know sine of theta, right? It's 2/3. If I can figure out cosine of theta, then I'm done. Now I'm going to do it like I always do it, just to be consistent. First of all, with these kind of problems, you always have to know where your angle is. First of all, sine theta equals 2/3. What quadrants is the sign positive? One and two, right? Actually, I don't have to do this. They tell me, wow, they tell me where the angle is. 0 to power 2 is quadrant 1. So basically, they just come out and tell us. So that makes it easy, because you know what quadrant 1 is? All the trig functions are positive. So I don't have to worry about, oh, do I need to add a negative sign or not? Everything's positive. So what I'm going to do is I'm going to take my sine, and I'm going to create a right triangle, just like we've done many times before. Sine of theta is 2/3. Sine so katoa, so opposite over hypotenuse. So opposite must be 2. Hypotenuse must be 3. I can use the Pythagorean formula to figure out my last side here. Hypotenuse squared 9 minus the other side squared 4. Looks like the bottom side is square root of 5. So now look, sine of 2 theta is 2 sine theta cosine theta. 2 sine theta, we can either get from here or just go up here. And then cosine theta, so ka is adjacent over hypotenuse. So when you multiply by all this out, you should get 4 square root of 5 over 9. Now, let me try and fit this on there for part B. Part B is cosine 2 theta. I'm going to go once again look at my formula sheet and see if, because with 2 theta I'm sort of stuck, but my formula sheet under double angle, 2 theta is interesting, cosine 2 theta is interesting because there's actually 3 choices. I almost always just do the first one, which says cosine squared of theta minus sine squared of theta. So what's cosine of theta? So ka, adjacent over hypotenuse, but it's squared, minus sine of theta squared. Sine, either look at here or way up there. Either way you want to do it, it's 2/3 squared. So this is 5/9 minus 4/9. Looks like cosine 2 theta is 1/9. Now, let me make some room. Part C, so this is a pretty tedious problem. Just write it down here. Part C was now half angle. And if you go to a formula sheet, there's formulas for half angles. And it is plus or minus square root of 1 minus cosine theta. So once again, we're doing the same thing here. When you have a theta over 2 inside the trig function, that's sort of hard to work with. But this formula all of a sudden converts it, and now I'm back to just having to deal with cosine of theta, which I can handle. However, plus or minus, we have to determine which it's going to be. The way you do that is your initial angle they said theta is between 0 and pi over 2. So if I don't know what theta over 2 is, I just divide all three parts by 2. And you realize that theta over 2 is actually going to be between 0 and pi over 4, which is all in the first quadrant. And since the sign in the first quadrant is positive, we know this is going to actually be a positive. So this is now going to be our equation. Cosine of theta, if I go back to my triangle, cosine, so ca, adjacent over hypotenuse, square root of 5 over 3. So this is actually sort of messy algebra. What I'm going to do first is I'm going to combine these two terms in this numerator. I'll make the one 3 over 3. So by the time you do that, it looks like this, all over 2. And now I can simplify this complex fraction. And then, actually this is not simplifying anymore, so I'm sort of done. It's pretty messy, but that's when I'm done. I'm done with that. And then the last one, cosine theta over 2. This still applies. I'm in quadrant 1. I go get my formula for the cosine theta over 2. Once again, it's plus or minus square root, but I know it's going to be positive. So let me just write the square root of, and then you see that it's 1 plus cosine theta over 2. The sine of theta over 2 is 1 minus. The cosine theta over 2 is 1 plus. Now it's just a matter of plugging in. Cosine theta is square root of 5, square root of 5 over 3. That whole thing over 2. Actually, if you go through the math, it ends up looking the same as this, except instead of a minus, it's going to be a plus. Whoops. So you have square root of 3 plus square root of 5 over 6. All right. The last problem. Actually, the last problem is just like the one we did. Let me get a new sheet so I can hopefully fit it all on here. 43. Once again, we're going to find sine 2 theta, cosine 2 theta, sine theta over 2, cosine theta. So I won't write that down. It's 4 parts again. But for this one, the information is tangent of theta equals 3/8. And they say theta now is going to be from pi 3 pi over 2. Where is this? In our circle, that's quadrant 3, right? Quadrant 3 is where actually the sine and cosine are both negative. So when I go do my, okay, So I have to be careful because I'm going to have a bunch of negative stuff. So now let's do sine 2 theta, 2 sine theta cosine theta. Let's go create my right triangle. Tangent of theta equals 3 over 8. So-called TOA. TOA. Tangent is opposite over adjacent. Pythagorean formula. 3 squared is 9 plus 8 squared is 64. And I believe square root of 3 is a prime number. It doesn't simplify. So now, 2 sine theta, sine opposite over hypotenuse, times cosine theta, so ca adjacent over hypotenuse. 2 times 3 is 6. It's like 48. Square root of 73 times square root of 73 is just 73. Looks like 48 over 73. B, cosine of 2 theta. I think I'm going to use that equation. Cosine squared theta minus sine squared theta. So cosine of theta, we did it up here, is 8 over square root of 73. So we're going to square it. Minus sine theta is 3 over square root of 73 squared. So this is 64 over 73 minus 9 over 73. Looks to me like it's 55 over 73 if I didn't make any math errors. That looks correct. Now let's finish up with the half angle. So sine. Now we have to confirm, let's figure out where we're at. By that I mean, here is the limitations on theta. Of course, half angle means divide everything by 2. And this ends up being 3 pi over 4. So pi over 2 to 3 pi over 4, where is that at? That's actually in quadrant 2. So the half angles are going to be in quadrant 2, which means the sine is going to be positive, but the cosine is negative. So when I go get my formula for the sine for the half angle, I'm going to use the positive. So it's going to be 1 minus cosine theta over 2. Cosine theta, so ca 8 over square root of 73 all over 2. That looks very messy. Let's go ahead, let's try and rationalize this. Let's go off to the side. So multiply top and bottom. So this is 8 square root of 73 over 73. And then of course 1 ends up being 73 over 73. So I end up with 73 minus 8 square root of 73 over 73 all over 2. If I combine those, 73 minus 8 square root of 73 over 146. Wow, very messy. Now the cosine, I'm not going to go through all the math, but what I'm going to first of all show you is that we have to use the negative formula since we're in quadrant 2 and the cosine quadrant 2 is negative. And it's going to be 1 plus cosine of theta over 2. Turns out if you do plug in everything again, it's going to look just like this, except you have a negative out front instead of a negative here. It ends up being plus. I'll let you work that out on your own, but oh, you know what? I made a bad assumption. You guys probably saw this. Oh, you know, I see I have the answers here, which of course you want on the test, but I made a math there, which is pretty common. You know what I did? When I plugged in cosine of theta, cosine of theta comes from up here, which is in quadrant 3. And you know what? It should be negative. So actually, this is real-time correction, because I don't want to make this video again. So you know what I'm going to do? I'm going to redo this problem, because I messed up, but I don't have time to redo it. So for C, let me write it again, and I'll explain to you my mistake, which is very common. Even I make mistakes. We know this is the formula. Now, so when I get ready to do this, I had to go find cosine of theta. And that goes way back to the beginning. I created my right triangle based upon this information, and I said it's quadrant 3. Quadrant 3 means the sine and cosine are both negative. So when I went to get the cosine of theta, so ca 8 over square root of 73, it should have been a negative number. So it's 1 minus a negative 8 over square root of 73. All that over 2. So basically, the math is all the same, except now what happens is, when it's all said and done, instead of the minus here, that should have been a plus. So if I'd done the math correctly, I would end up with 73 plus, because you subtract a negative, it's plus, plus 8 square root of 73 over 146. Very messy, but now that is correct. And therefore what I said is true about cosine theta over 2. We know it's going to be negative, but the equation is this. And now it is going to look the same as this inside here, except it's going to be different inside. So the negative is still out front. You'd have 73 minus 8 square root of 73 over 146. All right, sorry about that. I hope you understand this now. And actually, this is a good example of how this stuff can be sort of tricky. So my apologies. I guess I did 43 problems. This may have been the first one I made a bad mistake on. I can't remember. Anyways, all right. So those are all the test review problems, and that's pretty much what the test is going to look like. So work through these and prepare yourself.